increasing. So generally what they will say is the bandwidth will almost always be at least as high as estimated by this method. So how much ever number of poles you consider and estimate the bandwidth, the final bandwidth what you do by circuit analysis will always be very, very high when compared to this method. And first order estimate is going to give us the most nearby value for bandwidth. Such information is almost never available. So when a system is given, you must know what is the bandwidth. So for that, what mathematical technique I am going to follow? I am going to follow this open circuit time constant method. Okay, so that is going to help me in estimating what is the amount of bandwidth I can find for a particular network. So how will you do this for a network consisting of resistors and capacitors? So we have steps. So first to find the effective resistance Rj naught facing the jth capacitor with all the capacitors removed. So remove all the capacitors, or I can say open circuit all the capacitors. Find the resistance Rj naught, effective resistance Rj naught. Find the product tau j naught equal to Rj naught into Cj. You know, tau time constant tau is equal to Rc, right? First to find the effective resistance, then find the time constant tau j naught equal to Rj naught into Cj. So 0 refers to the open circuit condition. Okay, so if I like that, you sum all the time open circuit time constants, and you know after summing all the time constants, you have to take inverse. That will give you the estimate of your high frequency cutoff. So this method is going to be very, very simple. So method of OC is very simple because every time you calculate, you are just going to consider only single resistance and single capacitance. So you are just going to see the circuit, analyze the conditions, and find out what is tau I. Tau I is equal to Ri into Ci. So for one particular Rc value, you find what is the tau. So if you have 10 combination of R and C, you find tau 1 to tau 10. Add everything. Take inverse, you get the estimate of the high frequency cutoff. The greatest value of the technique lies in identification of elements which are going to limit the bandwidth. We assume that predominantly R and C are going to control the bandwidth because tau is equal to RC and bandwidth is proportional to 1 by tau. Correct? So we are going to identify those elements which are going to help us with providing the estimate of bandwidth. So reciprocal of each time constant, you add an inverse reciprocate that, you get the bandwidth. So this each time constant represents a local bandwidth degeneration. So every time one time constant means it is going to be accurate. When you add the time constant, then the bandwidth will decrease because denominator is keeping on increasing, right? So that's what they say. Every time constant you represent, it is going to add up and it is going to reduce the bandwidth value. So this method says that the linear combination of these individual, if you add, you will get the total bandwidth. So add all the time constant, take the reciprocal, you will get the total bandwidth of your systems. And this method of OCs is very, very effective because we identify the different components in our circuit which are going to be the main cause of providing bandwidth. So that is, we are doing it directly. So it is going to remove all the bottlenecks which are available in the computation of bandwidth. So there are many techniques show that the OC estimates are going to be reasonably fine, and they say that first order is going to be providing you the best estimate. As you go to higher number of orders, the bandwidth degradation starts, and the estimate will not be accurate. Even if you have multiple number of poles, if you have one dominant pole, still your bandwidth is going to be dominated only by that pole. So even if you take more number of higher order of a system, but assume that only one pole is going to dominate, then your bandwidth will not be affected by other poles. So this pole time constant alone will dominate the bandwidth of your system. So many examples, you have operational amplifiers, all these, they go for dominant pole compensation because this dominant pole compensation, if you perform, they are going to provide you the best bandwidth available for transmitting the signals. Okay, so that is why all the circuit, all the networks will go for this particular method to estimate the bandwidth. And in open circuit time constant method, we always say that single pole is going to give you the best bandwidth estimate, and higher the number of poles, bandwidth starts degrading and the estimate is not going to be that accurate.